Hello dear students, in this lecture we are going to discuss sign convention. So let us first draw lenses. I am drawing lens in the dotted fashion because the analysis we are going to discuss is applicable for both of them. Means any type of lens you can assume and the result will be the same. Let's suppose this is uh, this configuration you can understand as a type of coordinate axis. How? Let's see. Since this is a lens, it must have a optical center at this point. I'm drawing over here. So this point will be considered as origin. Okay, this is be considered as origin. So you can say first point we have discussed, origin will be considered as optical center of the lens. Similarly, we can also say that all the distance means every time you keep the object in left side of the optical center above principal axis. This is the principal axis. So as per convention, we always let us also number them. This is the first point. This is the second point we are discussing. Second point is means all the object distances will be considered left from optical center, means left from optical center like this is left, and above the principal axis means every time we will place our object in this fashion, this manner. Okay, so this is our second point. So you can also write object is placed over principal axis. Okay, on the left side you can also write a third point. Similarly, we can say a third point is you can say that all the distance will be calculated from optical center. So you can write all the distance, all the distance, all the distance along principal axis means like this. Along principal axis means if we have to calculate the position of this point, we will calculate from optical center, means we are going along the principal axis. So this is what we have, right? All the distance will be calculated along the principal axis from optical center. Optical center. Okay, so this is the case. Similarly, more points we can write about the sign convention. And apart from that, we can further simplify or further explain, further elaborate this point. We have right, all the distance will be calculated along the principal axis from optical center. So one point we can also mention here is that distance measured in the direction of incident ray is taken positive. Obviously, the distance which we are going to calculate is from optical center. From optical center, if we go in the direction of incident ray, listen it again. If the object distance or any distance we are calculating, if we are going in the direction of incident ray from optical center, then that distance must be positive. Okay, its opposite is also true. Distance measured opposite to the direction, opposite to the direction of incident ray is taken negative, right? It's taken negative, you get right. Let me explain this point in further detail. Let's suppose we have a lens. Let's take convex lens. In this lens, let's draw its principal axis first. Let's suppose a ray is coming like this. Ray is coming like this. So what does it mean? From optical center, remember all the distance should be calculated from optical center. This is the optical center. Now, if we have to calculate distance of, let's suppose, this object like this, mm, like this. So, for calculating this distance, in which direction we are going from optical center, you have always go from optical center. From optical center, in which direction we are going to calculate this distance? We are going in the direction opposite to incident ray. Incident ray is rightward in the direction, and we are going in left, means we are going opposite to the direction of initial ray. Okay, incident ray, you can say incident ray is initial ray in this case. So this distance must be negative. Again, let me clarify it in further detail. If a ray is coming like this, then in that situation, we have to calculate this distance as positive. In that situation, this distance will be positive. Students, always keep in mind that if we go in the leftward direction, then the distance must be negative, and if we go in the rightward direction, the distance will be positive, which is not true always. Always keep in mind, always the distance, calculate the distance in terms of direction of incident ray. If we go in the direction of incident ray, then the distance will be positive, otherwise it will be negative. Okay, so this is the point we should have discussed. Okay, similarly we can write the 4 point. Point number 4, it is length above principal axis is taken positive, and that below principal axis is taken negative. You can also write length below the principal axis is taken negative. Okay, so these were few important points. Now let us further discuss uh, notation. So you can write object distance is denoted as u. Object distance is always denoted as u. Image distance, again I'm reminding you that this distance must be calculated from optical center. All the distance must be calculated from optical center, considering sign convention in mind. Image distance is denoted as v. Similarly, focal length is denoted as f. Okay, so these are few you can say notations. Now let's discuss the same about the height. Means height of object is denoted as HO. HO means the height of object. H means height and O means object. Height of image is represented as or is denoted as HI. Got it? HO means height of an object and HI means height of image. Okay, so this height needs to be calculated from optical center. Means let's suppose an object is placed over here like this. Then what will be its height? Its height will be calculated above the principal axis. This is the principal axis. The distance, the height, this object is moved upward in this direction, means the height toward which we are going to calculate this, means this height is object height. Okay, so this is the object height. That's it. One last thing we can also discuss in this module, that let us draw convex lens. This is the convex lens and this is the concave lens. One convention we can keep in our mind is that it is the principal axis. Now about convex lens, we can write the primary focus of a convex lens is positive. Always keep in mind. And the primary focus of concave lens is negative. Okay, about primary foci we have already discussed in our earlier lectures. So this is the convention you should keep in mind about primary focus of concave and convex lens. Okay, so that's it.